In this video, we're going to look at graphing our quadratic functions that are given to us in standard form. Now this is standard form. Our function is equal to ax squared plus bx plus c. And that should look familiar because that was our same standard form when we were when we were factoring our functions. This a, b, and c becomes important to us as we do several things through graphing and solving our quadratic equations. The first thing we're going to look at is what this value for a does. Now what we're going to write down isn't going to make much sense to you here in the beginning, but as we look at more and more examples, it's going to become more and more clear. So the value of a determines for us the shape of the graph. So it's always going to be a parabola, it's always going to be U-shaped, but if a is negative, so if a is less than 0, it's flipped, meaning that it opens down. An example would be a equals -2, or a equals -1/2. Now, the other two things that can happen, our graph can be either really skinny, opening up or down, or really fat, opening up or down. That's our non-mathematical description. The description mathematically is that they are stretched or compressed. The stretch is going to happen when your absolute value is greater than 1. So think of it this way. Your a value is bigger than 1 or less than -1. So the number itself is bigger than 1, and then it can be positive or negative. That's what the absolute value means. And then the compression happens when we're less than 1. And again, think of that as the number itself is less than 1, and it can be positive or negative. So for right now, we're just going to write these down, and we'll keep revisiting this same thing over and over and over again, because that a value, no matter what form I'm in, stays the same. The b and the x change, but the a value stays the same, and it means the same each and every time. So we'll talk more about this as we do more and more examples. When we are graphing in standard form, the most important key feature is your vertex. To find your vertex, you are going to use this formula, x equals -b/2a. That's going to give you the x coordinate. So to find the x coordinate, you are simply going to determine your a, b, and c, and then plug into that formula, x equals -b/2a. To find your y coordinate, you take what you got there and you plug it in to the equation. We're going to look at an example in just a moment. And then our other important key feature, we're going to look at all of them, but in particular the ones that we want to find, our axis of symmetry. Remember, that's always going to be a vertical line that goes through your vertex. So it's always going to be x equals and the x coordinate of the vertex. So it's going to be found using that same -b/2a. And we want to remember that it's going to always be an equation of a line. X equals a number. All right, let's take a look at our example. So the function that we are using right here, g of x, is -x squared plus 4x minus 3. This should look familiar because we just did a table of values with this in our notes. And I did that on purpose because the table of value takes up a lot of room if you are doing all the arithmetic by hand, and I knew we didn't have room on this paper. So we did that one in our notes. We are still going to go through the whole process. We're going to find our vertex, we're going to create our table of values, and then we're going to graph, and then we're going to give our key features. All right, so remember we were talking about when we do a table of values with our quadratic functions, we want the vertex in the middle. So the first thing we need to do is find the vertex. To start that, I need to determine what my a, b, and c are. So your a is always the number in front of your squared term, so -1 in this case. Your b is the number in front of your x term, so 4, and your c is -3. So a is -1, b is 4, c is -3. To find my vertex, which is what I'm going to do first, before I create my table of values, because I want the vertex in the middle, I'm going to use negative b over 2a. That's the formula. I'm going to replace 4n for b. I'm going to replace negative 1n for a. So I get negative 4 over negative 2, which is 2. So the x-coordinate of my vertex is 2. To find my y-coordinate, I'm going to go back to my function, and I'm going to plug in 2. Plug in 2, plug in 2. So I'm going to do g of 2, and I'm going to take out my x, and I'm going to plug in 2. Then I'm going to use my order of operations. So first I'm going to do 2 squared. 2 times 2 is 4. Remember that negative just gets brought down. It's not being squared. 4 times 2 is 8 minus 3. So I get negative 4 plus 8 is 4, minus 3 is 1. So my vertex is 2, 1. Then I'm going to use my vertex to create my table of values. Pause if you need to. Let's do our table of values. You may go down into your key feature space. That's okay. All right, here's what we're going to do. We're going to take our vertex, 2, 1, and I'm going to put it in the middle of my table of values. So I'm going to come down to the middle, and I'm going to do 2, 1. I'm going to label that as my vertex. Remember, I can't just randomly pick my values for x this time. My values for x with a linear equation, I could just pick any points I wanted, and my graph's always going to turn out fine. With a parabola, I want to see my vertex, so my vertex needs to go in the middle. Now, I'm going to count down, so 2, 1, 0, and count up, 0, or 2, 3, 4. And then I'm going to use the table of values that we created in our notes to fill in the rest. So when I plug in 0, I got negative 3. When I plugged in 1, I got 0. When I plugged in 2, I got 1. When I plugged in 3, I got 0. And when I plugged in 4, I got negative 3. And we're going to put a little note, see notes in spiral for work. Just so we don't look back and go, where did I get those numbers from? I do want to point out my symmetry. Notice on either side of my vertex, those are the same. If they're not, and your x's were spaced the same, then you've made a mistake somewhere. All right, now I'm going to plot my points. So 0, negative 3. So plotting this point, 0 left, right, down 3. 0 left, right, down 3. And then 1, 0. I'm going to go to the right 1 and up and down 0. And then 2, 1. I'm going to go to the right 2 and up 1. 3, 0. I'm going to go to the right 3. 1, 2, 3, and up and down 0. And then my last one, 4, negative 3, to the right 1, 2, 3, 4, and down 1, 2, 3. Now remember, when you connect these, it's a smooth U shape. And let me actually do that a little bit better because I went above my vertex. And I want my vertex to be my highest point because that's the way the vertex works. It's either going to be your highest point or your lowest point. Not super great, but you get the idea. Smooth U shape. And then now we're going to look at our key features. So you can take up all your space on the bottom for your key features. First of all, notice that this opens down. Which means that your vertex is a max. And your vertex is the point 2, 1. Your y-intercept is going to be where your x is 0. So you can either look right here on your graph, 0, -3, or you can look right here in your table of values, 0, -3. In the last video, we wrote it just as -3. We're going to write it as a point this time. Our x-intercepts, also known as our zeros, we're going to write these as points as well. That's going to be where your y is 0. So we can either look here at 1 and 3, or we can look here on our chart at 1 and 3. So I'm going to list these as 1, 0 and 3, 0. And then axis of symmetry. I'm going to abbreviate that as AOS. Remember, your axis of symmetry is going to be the vertical line that goes through your vertex. That's at x equals 2. It's always going to be x equals and the x coordinate of your vertex. You need the whole thing. If you just say 2, it's wrong. You need the x equals because that's what makes it an equation of a line. And then last but not least, domain and range. I know this is a lot. So domain, you look left to right. As I look furthest to the left, sorry, I was looking for my arrow there. I've got an arrow. Furthest to the right, I've got an arrow. So I don't have anything left or right that stops me. Domain is all real numbers. As we discussed, that's going to be the case most of the time. Almost always, well, always if it doesn't have context. If I tell you that there's context, meaning behind your x and y, then your domain might change. But if I'm just looking at a graph, it's going to be all real numbers. Now the range, we look for our highest and our lowest. So my highest point is right here at 1. And my lowest point, I have arrows, so it goes down forever. Now, the fact that we are opening down and our vertex is a max, that tells us that my range is going to be a y is less than or equal to, and in this case, 1. 1 is the highest, and all my points are beneath it. So my range, y is less than or equal to 1. And that is it. That is all of our key features for this graph.